Hello everyone, welcome back to the channel The Univ Sin Theta. As a part of the series exploring the world of integrated circuits, today we are going to understand and break down what's more important, area, power or timing. But before that, let me remind you the continuation of the Moore's law will be out soon. How do you choose between optimizing for area, power or timing? It all sounds like fancy, but in reality it's a tough trade-off game. What's more important in digital design in the big three? At hardware level, we always juggle between these three constraints. How much silicon does the design occupy? How much energy does it consume? Or how fast it performs? Telling to optimize all three constraints work only in an ideal world. But in the real world, we have various challenges. We can't optimize all three at once. If you make one better, the other becomes worse. Consider a small example of a ripple carry adder. It adds 2 bits, taking carry in and giving the sum along with carry out, and continues like a relay race. But here, the problem is the delay. To compute the second set of addition, we'll have to wait for the carry out of the first set. One common way to fix it is, instead of waiting, as transistors language is binary, we assume carry will be 0 or 1 and compute both possibilities in parallel and use a multiplexer to pick the right one based on the actual carry out when it arrives. This is the faster, but as we have some added logic, area increases, effectively increasing power too. So which factor should we optimize to optimize the device as a whole? Pause the video and think for a while. You would have noted similar problems at some point. This is where context matters. Ask questions like, is this logic on the chip for battery powered IoT? Then power might be priority. Is it for a real-time system? Then timing should be the priority. Is it for smaller and cost-effective design? Then area should be on focus. At the end, everything comes down to market export and development of humankind. Based on the application you are designing and the constraints you have, you are supposed to decide. The question how to decide requires a lot of intuition, planning and understanding on the design and the trade-offs. A designer needs to define the goals of the design, measure area, power and delay post-synthesis, simulate various architectures, analyze the trade-off and pick what gives the best cost-to-performance ratio. At the end, every choice you make while designing, especially digital designing, is a balancing act. One factor is improved at the cost of another. The key takeaway is to measure everything, compare and choose what gives you the most value for the use case. The real skill is not only designing but also choosing wisely. Let's know a bit on what industry does. In advanced chips like Apple's M series or AMD's Ryzen CPUs, timing is critical, especially on the critical path. Then comes power and area constraints. We can prioritize them by generalizing and understanding, like for smartwatches, power more than area, then timing. For high-end CPUs, timing more than power, then area. For edge AI, timing almost equal to power, then area. For mass ASICs like IoTs, area more than power, then timing. Also, recent advances like approximate computing lets us sacrifice a bit on accuracy to save power and area. In low impact parts like image processing, we can simplify the logic to use less power. And now with advancements of AI based EDA tools like Cadence Cerebrus or Synopsys DSO.ai, we can train the tool to find the best trade-off configuration. They literally find out the best combo of PPA, power, performance and area across millions of possibilities just from the provided RTL design. Recently, Google used similar methods in designing TPU, Tensor Processing Unit. Using reinforcement learning, they optimized floor planning and logic path delays better than human experts in some cases. Again, everything comes down to the application and budget. It's not just about designing fast or low powered or smaller circuits. It's about designing smart, most optimized ones. Don't forget to like, share, and subscribe for more such content on science, space, and technology. See you in the next one.